Hey there, future math wizards. If you've ever struggled with unit conversions, don't worry. You're not alone. But guess what? After this video, conversions will feel like a breeze. So, in this lesson, we'll break down the easiest and most effective ways to convert between different units. We've got over 10 practical examples to help you master conversions with confidence. This video is a continuation of our previous lesson, so if you haven't checked that out yet, I highly recommend watching it first to build a strong foundation, and I will put the link in the description. But if you're ready to dive in, let's get started. So, today, we have cool real-world examples for you. Imagine a strong wind blowing at 30 meters per second, that's super fast. But have you ever wondered how fast that is in kilometers per hour? Well, that's what we're about to find out. Let's break it down together. Alright, so we are given a wind speed of 30 meters per second. Our goal is to convert this into kilometers per hour. But how do we do that? Let's go step by step. We know that 1 kilometer equals 1,000 meters and 1 hour equals 3,600 seconds. So, to convert from meters per second to kilometers per hour, we use this conversion factor. Wow! That means the wind is blowing at 108 kilometers per hour. That's as fast as some cars on the highway. To give you a real-world idea, strong hurricane winds start at around 119 kilometers per hour, so this wind is almost at hurricane level. Imagine walking against that wind, pretty intense, right? In this example, we'll convert a typical airplane speed of 550 miles per hour into meters per second. Buckle up because we're about to take off into the world of unit conversions. We are given a speed of 550 miles per hour. Our goal is to convert this into meters per second. But how do we do that? We use a conversion factor. We know that from last video. 1 mile equals 1,609 meters, and 1 hour equals 3,600 seconds. So, to convert miles per hour to meters per second, we use this formula. That means the airplane is flying at 245.8 meters per second. That's almost 900 kilometers per hour. Imagine standing still while a jet zooms past, insane speed. In this example, we're diving into the world of fluid dynamics and learning how to convert viscosity from centipoise to the SI unit Pascal seconds. Stick around, and let's make science fun and easy. We are given a viscosity of 1,500 centipoise for a certain oil. But in science, we often need to work with SI units. So we need to convert this to Pascal seconds. But how? The key conversion factor we need is this one. Now, all we need to do is divide 1,500 centipoises by 1,000 to get our answer. So, the viscosity of the oil is 1.5 Pascal seconds. Pretty straightforward, right? To put this into perspective, the viscosity of water is about 1 over 1,000 Pascal seconds. While honey is around 10 Pascal seconds. That means this oil is 1,500 times thicker than water but still much thinner than honey. So, here, we're talking about engine power and learning how to convert horsepower to the standard unit of power, watts. Let's rev up and dive right in. We're given a sports car engine that produces 350 horsepower. But in science and engineering, we typically use watts to measure power. So, let's convert it. The key conversion factor is 1 horsepower equals 746 watt. Now, we just multiply 350 by 746 to get our answer. So, this sports car engine produces 261,100 watts or about 262.1 kilowatt. That's a lot of power. Right. To put this into perspective, an average home uses about 1 kilowatt at any given time. That means this engine could power over 260 houses at once. Here, we're diving into the insane power of lightning and converting its energy output into megawatts. Let's electrify our knowledge. We know that a lightning bolt releases about 5 billion joules of energy in just 0.002 seconds. But how much power does that equal in megawatts? The formula for power is power equals energy over time. Now, let's substitute our values. That's 2.5 billion watts or 2,500 megawatts. To put this into perspective, a typical nuclear power plant generates about 1,000 megawatts. So, a single lightning has more than twice the power output of a nuclear plant for that brief moment. What if I told you that the pressure in your car tire is way stronger than the air around us? But, how strong? Let's break it down. Here, we're taking a simple tire pressure measurement and converting it into pascals, the SI unit of pressure. Ready? Let's go. We have a tire with a pressure of 32 pounds per square inch, SI. But in physics and engineering, we often use pascals instead of SI. So, let's convert. The conversion factor we need is 1 psi equals 6894.76 Pascal. Let's multiply. So, the tire pressure is 220,632.3 pascals. To put this into perspective, atmospheric pressure at sea level is about 101,325 Pascal, so your car tire is holding more than twice that pressure. Venus, the Earth's so-called twin. But did you know that standing on its surface would feel like being 900 meters underwater? That's because Venus has a crushing surface pressure of 9.3 megapascals. But what does that mean in terms of atmospheres, the pressure we experience on Earth? First, convert megapascals to pascals. Since 1 megapascal equals 1 million pascal. So, we multiply these numbers. Now, let's convert pascal to atmospheres. We divide. And we get 91.8 atmospheres. That's nearly 92 times Earth's atmospheric pressure. Imagine carrying the weight of 92 Earth atmospheres on your shoulders. No wonder spacecraft don't last long on Venus. So next time you hear about Venus, just remember, it's not just hot, it's extreme. A farmer owns 5 acres of land. But have you ever wondered how big that is in square meters? Let's find out. First, we need to know that 1 acre is equal to 4,046.86 square meters. So, to convert 5 acres, we multiply to get the answer. Did you know that seawater is denser than fresh water? That's because seawater has about 3.5% dissolved salts, mostly sodium chloride. These extra particles increase the mass of the water without significantly increasing its volume, making it denser than fresh water. That's why you float more easily in the ocean. But how do we convert that density into different units? Let's find out. In science, we often switch between units. Here, we need to convert grams per cubic centimeter to kilograms per cubic meter. This means that seawater's density is about 1,000. Next time you're at the beach, remember, physics is keeping you afloat. Imagine a pipe delivering water at a rate of 50 gallons per minute. But what if we need to express this flow in cubic meters per second? Let's break it down step by step. So, the final answer is 0.003 cubic meters per second. This conversion is super useful in engineering, plumbing, and environmental studies. Next time you see a flow rate in gallons per minute, you'll know exactly how to convert it into metric units. Here, all you have to do is follow along step by step, it's that easy. And if you ever get stuck or have any questions, drop a comment below. I'll be happy to help you out. Here, all you have to do is follow along step by step, it's that easy. And if you ever get stuck or have any questions, drop a comment below. I'll be happy to help you out. That's a wrap for today. If you found this video helpful, hit that like button, share it with your friends, and subscribe for more easy-to-follow science and math tutorials. And don't forget to tap that notification bell so you never miss a new video. See you next time.